Welcome to Technically, a webinar series dedicated to the technical challenges of making the web accessible. This month, our presenter is SVG and data visualization expert Doug Schepers.
Hello, everyone, and welcome to this September edition of Technically. I'm Michael Beck, your host and moderator, and this month we have Doug Schepers with us, dataviz and SVG expert, and what would you say, CEO of Fizz Studio?
Oh, pretty much everything at Fizz Studio.
Everything at Fizz Studio. He'll be discussing data verbalization today. Making images and data visualizations accessible to everyone, which is something we haven't touched on quite that deep yet. So Doug's going to take his deep dive today, and over to you, Doug.
Great. Thanks, Michael. Okay, so I would want to start off with a little intro. Who am I? And my name is Doug Schepers, obviously. And I've been coding SVG and JavaScript since around 2000. I was doing other kind of programming before that, so I've been a programmer for a while. I worked at W3C for 10 years. I was on the SVG working group, web apps. I started the web audio working group, if you know what that is. I am not technically an accessibility expert by training. I have the same sort of imposter syndrome that many of you probably feel when dealing with accessibility. I am sort of a niche accessibility expert. I'm an expert in accessible data visualization. So that's a very tiny niche within a niche. I'm also the founder of Fizz Studio. We're an accessible data viz startup. And I recently started a job at UNC, University of North Carolina at Chapel Hill, as a digital accessibility consultant. That's sort of my side gig. Thank you for having me here. Let's jump into accessible data visualization. So the first thing I want to talk about is colors. You may have heard of web safe or colorblind safe color palettes. There's one that I'm particularly fond of, and that is the Brewer palette. This is done by someone named, I cannot remember her name, but it is not Judy Brewer, if you know the W3C WCAG person, but it is Dr. Brewer from, I think, Pennsylvania. And she came up with this set of colors for maps. And there's sort of three ways to think about these colors. There's discrete colors. Discrete colors are for categories. They're for individual items that are distinct from one another. Then there's sequential. You'd use this, for example, when you are trying to show that some things are related in some way, that there is a series of things. And then you have diverging. Diverging is sort of something where it's going from one category to another category. And so discrete means it's quantitative. There's no perceived order. Sequential means that these are perceived order, uniform steps. And diverging means that these are two sequential colors. Why am I talking about these kinds of things? One, the Brewer palette has a lot of really great colorblind, safe, accessible options. And the second reason that I'm talking about when you use these kinds of colors is because accessibility is not just about accessibility for blind people. It's also accessibility for everyone, of course, but specifically people with cognitive disabilities, for example. By setting things up in a way that makes sense to people, that feel natural to people, you are setting yourself up for thinking about how to approach data visualization in the right way. In other words, how do you think about how people think about what you're showing on screen? So the rest of this talk is going to be about colors and which colors to use. No, colors are an important part of data visualization. But they are not the most important part, nor in fact do I think it's the most interesting thing to talk about in data visualization. When you look at most products, unfortunately, when they say that they are their data visualizations are accessible, what they mean is you can choose colors that are good for people with color blindness. Not to dismiss people with color blindness, but there are a lot of other issues you need to think about when dealing with accessibility. So this is pretty much one of the few times I'll be talking about color in this talk. I want to talk a little bit about complexity. And complexity, so this is a beautiful example of data visualization. It happens to be about the internet. This is a map of the internet. But I look at it and it's beautiful, but I really can't extract any information from it. I can appreciate the aesthetics of it, but I cannot really understand what's going on here. So you might have complexity like this. You might have a lot of complexity in your data. This is another example of complexity. We have what is, frankly, not a very attractive, beautiful image to look at, and I also can't get much out of this. I'm not saying that people can't learn to read graphs like this. They can. But I am saying that for most people, most of the time, whether you're trying to explore data or whether you're trying to explain data, you don't want to introduce this kind of complexity in your charts because you are excluding the vast majority of people from being able to understand what they're looking at. So my big takeaway here is complexity is the enemy of clarity in terms of data visualization. The big thing that you need to take away is think about your data visualizations as a poem, not as a novel. Make the most discrete, the smallest possible thing you can make in order to convey the idea that you are trying to convey. That is going to serve everyone. It also happens that will serve, for example, people who use a screen reader. The first thing that you need to think about when you're thinking about it, making a data visualization accessible is what is the absolute minimum I need to convey to this person so that I don't waste their time and waste their mental energy, waste their cognitive load. So you really need to think about, one, when you are making a data visualization accessible, what's the first thing, what's the most salient thing that you can take away from that? And in general, that is give them, before you do anything else, give them sort of alt text, give them an introduction that is, for example, North Carolina was the top top state in this or that figure. This is a stock market chart. The trend is upward from this value from 50,000 to 100,000, whatever it is. Give them a one sentence takeaway that they can approach to understand it from a cognitive perspective, from a screen reader perspective. And from there, they can decide if they want to drill down into the table of data or however else you're presenting that data. So that's the big takeaway there, is reduce complexity whenever you can. So here is an example of an accessible chart. How is it accessible? Well, for one, it's done in SVG. Which is scalable vector graphics, in case you don't know SVG. SVG, you see it used a lot for things like icons or very simple images, and you do see it used a lot in data visualization. I don't think that people really understand that SVG is like HTML in that you can completely control the document format, you can completely control aspects of the document to make it navigable in the same way that an HTML document is navigable. So what do I mean by that? Well, for one thing, we could say, boom, right off the top, there's an accessible SVG chart. Now, we don't need to tell them how many elements there are in it, but you tell them immediately when a screen reader hits this SVG, it will say accessible SVG chart. Then it will point out that there's an x-axis. We're setting context. We're saying here is the x-axis. Here are the things that we're going to be talking about. This is the dependent axis, or the independent axis rather. Then we have the y-axis, right? I'm going in order. I'm starting at the top. I'm saying this is a bar chart. Then I'm saying the x-axis. Then I'm saying the y-axis. And then I let them walk through the individual data points. Saturday, 8 hours. Sunday, 6 hours. Monday, 4 hours. Tuesday, 12 hours. By using this, by using an SVG, I'm able to actually let them drill into and tab through and get at all the data in the same way that they'd be able to get at it through a table. I want to talk how do we achieve this? Partly, it is just through using tabindex, things like that. But partly, we have these new standards coming out about Aria. So Aria is about categorizing different kinds of controls. At Benetech, there's an accessible data visualization task force. That's not actually part of Aria, but there is a task force working on helping inform the next Aria, generation of Aria standards. There are some new Aria roles in SVG. The graphics accessibility API mappings in the way Aria graphics module. And they have things like graphics document, graphics object, graphics symbol. And you can use these in your SVGs in order to make the screen reader understand what exactly the person is supposed to be looking at. I want to talk a little bit about screen readers. Not about screen readers themselves, but about how the information gets from the browser into the screen reader. So you start off with a document, say an HTML document. If you know about the DOM is the document object model. That is what the browser sees in a document, and then it presents that directly to the user. And that's a pretty straightforward transformation, right? Document gets turned into a DOM, document object model, and that's presented into the browser. It's a little more circuitous for a screen reader. For them, the DOM is converted into an accessibility tree. This is a subset of everything else that's in the document. So when I'm going back to this image here, there's a lot of things that we don't talk about in this image. I don't talk about the individual lines at the back that show sort of the tick mark lines that show what that help a user visually track going from 8, over across the screen. We don't mention those in Aria because they aren't useful to a screen reader. There's a lot of elements here that we simply don't have to mention. We don't have to mention that there's a sort of a 3D effect in this bar chart because that's not information that's adding to what the screen reader sees. So going back over here, we've got the document, we've got the DOM, and the accessibility tree is a subset of the DOM that is presented to the screen reader. After it goes into the accessibility tree, it goes into the operating system's accessibility API, and then it goes to the screen reader, and through the screen reader, it's presented to the user. So once you understand the flow of how the information gets there and understand how you can filter out pieces of information that are extraneous to the screen reader user, it's a little bit, an analogy might be when you have an image that is meaningful, you use alt text. When you have an image that is not meaningful, it's just decorative, you can just say alt equals blank. It's sort of like that. You highlight the things that need to be highlighted, and you sort of hide away the things that are extraneous. Let's step back and look at what is data visualization in the first place. So this is a fancy word for, or I say data visualization. I also say dataviz a lot. It's sort of jargon. It's a fancy word for charts and graphs and diagrams and maps. And a common metaphor in dataviz circles is that data visualizations are a story about data. And I don't dispute that. That's certainly true. It is a story you are telling people about the data that you're looking at. But I have a more functional metaphor, and that is data visualizations are a user interface for data. And my goal in this talk is to get you to rethink what a data visualization is. So many people say that data visualizations, I've heard this for years, data visualizations aren't accessible, can't be accessible. But in fact, data visualization is accessibility technology. I popped up on the screen here a spreadsheet, an image of a spreadsheet that shows the raw numbers for population for the 4 biggest countries in the world, Brazil, China, India, and the United States. or most populous countries rather. And I show the years from 2000, the populations from 2000 to 2016. So at this point, if any of you are able to see this image, I could ask you a question: which country of Brazil, China, India, and the United States, which of them has the highest rate, not the highest number of population, the highest rate of growth in population? And I could sit here and solicit answers. And the fact is, most of you would not be able to tell me right away. But if I show you a line chart that shows the rates of population, you can see that China has the highest population, but you can also see that India has a higher rate of growth because the angle of the line is steeper. And it's very interesting. When I showed this presentation to a person with low vision, they couldn't make heads or tails out of the table of data. But when I showed the line chart, they were able to immediately tell me that India had the fastest rate of growth. Now, this was a mathematical person who knows how to read charts well. But the point is, instantaneously, you were able to take the data from a table view is not very accessible. And in a dataviz role, in a line chart, is actually much more accessible. It's much easier to notice and think about patterns. It aids certain kinds of cognitive disabilities and low vision. It helps really reduce effort, and it helps you to catch attention in a data-flooded world. What it's doing is it's creating a functional model of the data in the minds of the audience, and there's nothing inherently visual about that. So Ben Schneiderman is a pioneer in what was called HCI at the time. We would now probably call it UX. Human-computer interaction has now sort of become a user experience, and he's also a dataviz pioneer. And he said, the purpose of visualization is insight, not pictures. And that's really where we're going here. The purpose of visualization is not pictures. So the immediate question might be, why is it visual then? Why do we do things visually? Well, because the visual channel is very broad. It's very fast, 10 million bits per second. 30 to 60% of the brain is dedicated to visual processing. This sort of corresponds to our fight or flight reflex. If you see something moving quickly towards you, you immediately have a reaction. It's the difference between seeing dinner or being dinner is the expression. In comparison, touch and hearing have a much lower bandwidth than visual information does. Vision is also multi-channel. I won't go into all the details here, but there's something called the saccade where your eye is moving around. You're constantly pulling in multiple pieces of information, correlating them in your mind. This helps us detect, match, and make sense of patterns. And we use these capabilities, these visual capabilities, to convey things in a way that's faster than we could do through serial access. So it's parallel processing with vision, serial access when we're listening to, for example, listening to numbers in a table. There's also something called the pictorial superiority effect. And again, the breakdown of the senses is, I've got a little pie chart made out of a brain with allocations of the senses. The allocations are not exact. They don't make, because we don't really know how exactly the brain processes different sensory information. But generally, between a half and 3/4 of our cognitive capacity is dedicated to visual processing. The pictorial superiority effect, it affects memory retention. So if I showed you this whole slide deck with just text, no images, you would retain that information, about 10% of that information after 3 days. However, if I add images that sort of help you frame the ideas in your mind, you will retain after 3 days 60%, 65% actually of that information. So this, and the curious thing is that this effect increases with age. You think little kids are very visual, they see pictures and things like that. Actually, once we reach a certain threshold, the older we get, I'm a 50-year-old, visuals become more and more important to me and more effective on me. And this increases with age. If you're interested in reading more about that, there's a book called Brain Rules by John Medina that talks about that a little bit more. So I mentioned cognitive load earlier. What is cognitive load? Actually, cognitive load can be broken down into a few different categories. There are different types of cognitive load. Intrinsic cognitive load is the bare minimum that you need in order to understand an idea. And then there's a bunch of extraneous cognitive load. These are all the things surrounding the idea that are actually distractions from you understanding the core idea. This extraneous cognitive load it's basically clutter, and there is some redundancy though. Redundancy actually is helpful. Saying things twice in different ways or multiple times in different ways can actually reinforce the main point. So redundancy actually has a function. When you combine the intrinsic and the necessary parts of the extraneous clutter, we get what's called germane cognitive load. This is stuff that people feel is relevant. It sets context. It helps people establish what they're trying to understand. Germane cognitive load is the brain looking for patterns within the clutter to develop context. Serial tasks, that is, say, tasks where you're doing one thing at a time, as opposed to doing multiple things at the same time, cost more cognitive load than parallel tasks. And this is why, for cognitive accessibility, visualizations are actually often very effective. It does introduce some challenges, though, and we're going to explore that. I'm going to be talking a little bit more about the brain and how it works, so I hope you'll bear with me, because I think it's germane to you understanding how to think about accessible data visualizations. There's something called the preattentive attributes. The preattentive attributes, these are features that are processed automatically by our visual memory, our iconic memory. These include color, form, position, and movement. And I'll show you some examples of each of these. Color, it's pretty obvious. There's things called hue, saturation, and lightness, HSL for the designers among you. And each of these sets one color apart from other things in the same set. Another feature is called texture. When we see that something has a different texture than other things, our eye immediately jumps on that. Then there's things like that comprise form, like orientation, alignment, collinearity, length, shape, size, curvature, width, added marks, intersections, spatial grouping, or numerosity. Numerosity being our inherent ability to see roughly how many of a thing there are. It usually tops off around 4 or 5 is when numerosity starts dropping off and we can't really instantly count. But up until that point, boom, our brain actually is counting those things immediately. So then under position, we have things like 2D position, stereoscopic depth, concavity or convexity. And under movement, we have size change, direction and velocity, rotation, and flickering. I'm going to take these animations off because the movement ones are so distracting to me as somebody with ADHD. I can't have them on the screen while I'm trying to concentrate and do a presentation. And I think it would also distract some of you. So several of these pre-attentive attributes, these automatic attributes, are ideal for quantitative mapping, and others are good for quantitative mapping. In other words, some of them are really great for showing numbers, and others are great for showing categories. The ones that are ideal for numerical or quantitative mapping are length, and you can see there you see 3 little lines and one is taller than the other. Immediately you realize, oh, that's how we use a bar chart. 2D position, this is like a scatter plot, and size. These are the 3 that are really great for quantitative mapping, and the rest of these you should consider as things for showing categories. To go along with these pre-attentive attributes, there's something called the gestalt principles. And this is one level up. It's a higher level pattern recognition that organizes all those different little things that our eyes and brains immediately grab. And it organizes these discrete elements into a unified whole. So some of these are proximity, where things are close to one another. When things are close to one another, you assume that they are a group. And I have 2 examples where you see proximity, you see things as a group, and then another one where there's no clear grouping. Things are a little more scattered. Then there's something called enclosure. Enclosure when we see things that are wrapped in another element and wrapped in another thing, we tend to think that they are somehow groups. Connection, if there's a line drawn between things, we think that somehow those things are connected. Our brains immediately think that. Similarity, if I have here some red boxes and some blue boxes, and they're not clustered together, but you think, oh, the blue ones are similar to one another and the red ones are similar to one another, and they are distinct from one another. Maybe so, maybe not, but our brains definitely see that connection. And as I'm showing you these, I invite you to try to look at these things and think that these items that I'm showing you are in fact not connected to one another. And it's actually difficult for you to do. It's difficult for me to do. Closure. This is an interesting one. I'm showing you a series of lines that seems to show the outline of a box. There are several breaks in it, but our brains fill it in and it looks to us like a rectangle. It's not a rectangle. It's a series of 3 different angled lines, but they look to us like a rectangle. And continuity. Continuity is interesting. I have 2 bars here, one bar in front of the other, sort of a dark blue bar and a light blue bar in front of it. But when I mouse over it, I can show you that, in fact, it's not 2 bars. In fact, it's 3 bars. It's just that because one of the bars is crossing over, it makes the one in the back look like it is a continuous bar. And even when you see that it's an illusion, when I dispel the illusion, you still see it when I go back to it. And then finally, there's common fate. Common fate is when things seem to be moving together, you assume that they are somehow connected. These are processed after your sense memory, but they're still pre-conscious. And they're processed in parallel with one another. Like preattentive attributes, there's little to no increase in the cognitive load. This is a really key concept here, this fast and slow mind. The fast mind is called System 1. It's fast, it's automatic, it's frequent, it's emotional, it's stereotypic, it's unconscious. This is where immediate reactions, this is where racism comes from. This is where very positive, our reactions to attractive people come from. These are immediate reactions that we don't have much control over. Preattentive attributes and gestalt principles fall into this. Then there's the System 2, the slow, effortful, infrequent, logical, calculating, conscious part of the mind. This is when we're looking at a data viz, the first thing that happens is we've got this preattentive, automatic assumption about relationships. But then after that, we can start thinking about meaning. So with data viz, the first thing we do is convey the properties of the data. And the second thing we do that takes more effort is we explore and we think about that data. But when we only give somebody serial access to something, in other words, we substitute a table for a data visualization, what are we doing? We are taking that serial access and we're forcing them to use it for both conveying the properties of the data and to explore and think about the data. We're increasing their cognitive load. So it's cognitively expensive, it's mentally taxing, and it slows task performance. We really want to try to avoid that in our data visualizations. This is why I keep saying, give them the gist, give them the ability to quickly assess how deeply they want to dig into something. This also applies to a table of data. Provide a summary for the table of data that gives the key takeaway. This is going to help everybody. So what we need to do is we need to reduce the speed and effort needed to accomplish tasks in a non-visual way. In other words, when we are making a data visualization, we also need to think about how it's handled otherwise. So in other words, in a non-visual way. We have different kinds of sensory memory. And when we see a data visualization, it goes into our sort of our visual or our sensory memory. Then it goes into our working memory, then our short-term memory, and then to our long-term memory. And at every point, or some information is being filtered out. The benefits of a data visualization are that it effectively acts as part of our brain. It acts as an external memory register. We can immediately access that information very quickly, going back and forth between what our brain is able to hold in at any one time and what we can see. And so what we really want to try to do is we want to try to emulate that kind of fast control with non-visual means as well. So there's something called affordance. Affordance is how you expose information or expose some functionality and also immediately show how to use that thing. So affordance and equivalence is not just a long-lost Jane Austen novel. This is an idea that we need to take each feature of the chart that includes an affordance and a set of tasks that affordance is geared towards, and we need to make an equivalent experience for someone who has a different way of accessing that information. One way we can think about doing this is to consider a data visualization as a document. So we have a title, we have where it came from, we have an introduction, we have a body. The introduction, in the case of a bar chart, for example, are the axes, the x-axis, the y-axis. I showed this before. We have the body, which is sort of the data itself, and then the conclusion. And the conclusion in a document is a paragraph, right? But the conclusion in data visualization is the actual insight that the reader has gained and the decisions that they've been able to make based on that data. You want to think about document order when you're making a data visualization. You want to think about what order the person is navigating in order to get to different parts of your document using, for example, tabindex. This idea is of adding information into your data visualizations, not just thinking about them visually. Something I call deep graphics. And deep graphics is basically alt text is a kind of deep graphic. It's when the graphic has more metadata to it that adds context and adds, for example, links to data sources and other things. I think the final thing I want to talk about around this sort of compositional view of data visualization is exposing each landmark in a sequence to provide context. So here we have the title of a document, of a data visualization. In this case, it's Snowfall by Decade in Columbia, Missouri, from set 1971 to 2010. And then we have the x-axis, which is the range of years. So 1971 to 1980, 81 to 90, 91 to 2000, 2000 to 2010. Then snowfall in inches on the y-axis. And so we're setting context at each point. And then we're showing the data. Okay, so we have 3 bars. You can see that these bars are decreasing. And the key here is we mark all those up in a way that a screen reader can actually understand. We have labels on them. And we provide access to each individual data item, the values. But then we also say things like we can pull out the high, we can pull out the low, we can pull out the range, give them the total, tell them maybe the mean. And here's a real key point, the trend line. Show that you can tell them, I told you as I was showing you the individual bars, these go down, right? This is a downward trend. And telling them right off the top of the bat saves them from having to try to deduct that themselves. So by pre-processing what your point is, by presenting your point at the beginning, you actually set them up to understand how they can drill through the data and derive what they need. Finally, I'm just going to say that my functional metaphor, I hope I've sort of showed you what I mean by this. The data visualizations are a user interface for data. Different types of data visualizations are optimized for performing different tasks like comparison to whole, comparison to other data points, trends over time, breakdowns of categories, connections between items, navigation and focus. And I just want you to understand that when you're thinking about data visualization, you should be thinking about all of these things. So the mission I have at Viz Studio is to make implicit interactions into explicit actions that will give the power to question and to answer to everybody. So there are a number of libraries and tools that you can use to make data visualizations accessible. You're going to be using a tool to make your data visualizations. You're probably not going to draw them by hand. Just make sure to choose a library that actually supplies the data in a way that is actually accessible. And the final thing I want to mention, there are various levels of data visualization accessibility. The first level is just generic alt text. Well, actually, the first level is not having any kind of accessibility at all. So that's base level. Let's go beyond that. The next, you can provide generic alt text. The next level up, provide detailed summary in alt text, so show market trends, the highest value, etc. Then the next step up, provide hidden content, that is, say, a table with the same information. And the next step up from that is actually to embed that information directly in the chart so that it travels with the chart and they're in the same context. And the last bit is basically think about it from a task-oriented perspective where you're giving them context for each choice that they're being meant to make. I think I'm going to end it there. If you want to get in touch, we have our alpha release of our software that is accessible. I think I'm going to stop there in order to make space for some questions.
All right, you actually answered someone right before you went into the alt text. Someone, David Annan, had asked, how should a caption look like for a typical dataviz? And then, like right on cue, you went right into discussing that the levels of dataviz accessibility. So if you want to go into that a little more, that'd be great.
Sure. The unacceptable level is not telling them that there's a database on the page at all, right? Using alt equals blank, right? The next level up is telling them that there is a bar chart, but telling somebody that there's a bar chart on the page is sort of like telling somebody a joke and not telling them the punchline. Most pages that have a chart on them, many of them, that's the main thing, right? That's the main point of that page, is to convey that information. And if you've made it inaccessible and just tell them there's a chart here, you're basically providing them nothing. So don't do that. What you should do is, for example, say things in the alt text like line chart showing market trends with a downward trend over the last year, or bar chart of costs with 12 bars, the highest value is 1,500. Then you might actually have a chart where you cannot make an accessible version of that chart. Somebody else gave you this JPEG or PNG or whatever of a chart, and your task is to make that clear to somebody. Well, that's how you do it, is you do it through alt text. However, if you are able to get access to the data, you can do other things like provide a table to them with the same information. This doesn't mean that you shouldn't have the alt text, right? This doesn't mean that you shouldn't have the summary. You should. But if I'm looking at a chart and the highest value is 1,500 and it's for North Carolina, that's great that North Carolina is the highest value, okay. But I might want to find out, because I'm from Missouri originally, I might want to find out what the number is for Missouri. So if they have that information available to a sighted user, you should provide that information to a screen reader as well. In other words, one way you can do that is by having, say, a hidden table. A better way, because tables and dataviz can often get out of sync, especially when one thing is hidden. I think we all know that problem of the accessibility ghetto, where there's one page off on the side or some piece of information that's hidden, that's only updated infrequently. It's really much better to have the data embedded into the image itself, into the SVG, for example, itself. So let them drill into that. And then what my software does is it lets them really drill into relationships and things like that. But at the bare minimum, I would say give them very good alt text, then that really says what is the point of this chart, not just this is a bar chart. And then go up in exposing more data to them as you can. Does that make sense?
Yeah, that makes complete sense. Hope that a little deeper dive was good for you, David. We have an anonymous attendee who asked, when you use SVG, how will you make them accessible? And I believe you answered that it's just part of creating an SVG itself. You can do that. Yeah.
So like each pie slice in a pie, each individual pie slice is its own element. Just like each individual paragraph in an essay is its own P tag, right? So each of those individual pie slices is a path, and you can add the metadata in there using a title element in SVG. You can also use Aria labeled by for the same purpose. and you can basically add the text version of that directly into the chart. You can say pie slice 1 value 30, right? Or in the title 30. The next one is 25, whatever. And you can add the data directly in there, and just make sure that you have it in the correct order, so that as they're tabbing through, they're seeing it in the same order that everyone else is seeing it.
Okay. Any thoughts or considerations on animated or time-based data visualizations?
Oh, it's something actually I've thought a lot about. One of the things immediately, I try to think of things in terms of the challenges and opportunities, right? The challenge for animation is that you might be excluding some people from understanding some things. The opportunity is that animation is actually a really effective way of drawing somebody's attention to a particular piece. So with animation, what I try to do is I use animation in order to draw someone's focus to a particular thing. But if I'm drawing someone's attention to like one bar, for example, has obviously things like flashing, flickering, etc. You need to be mindful of frame rates. Animations should be slow and discrete, and they should not be constant. They should be time limited, because if they're constant, it's going to be distracting to someone. If they're very frequent, if they're very fast, you risk giving somebody seizures. That's not a good risk to take. But if you use a pleasant, I'll say, animation, when you're doing that pleasant animation, you maybe use Aria Live to say, I'm drawing your attention to this thing, right? So don't just use one medium, right? Don't just use animation. Also say Aria Live, and then draw, maybe say, highlighting New York, 3.5 billion or whatever it is. Does that make sense?
Definitely makes sense to me. Let's see, what else do we have? How would you approach data visualization of say a geographical map?
Oh, right. That's actually something I've thought a lot about. Maps are interesting because we think of a map as sort of a single thing, but in fact, there are lots of different kinds of maps. And this gets back to my point about it being a UI for data. What is the function that you're trying to use with this map for? Is this a navigation map where you're trying to help somebody navigate a particular path? Is it something that's trying to show the relationship between different items? Or is it something like a choropleth? A choropleth literally means many places. It's a terrible name for something, for a data visualization. It was coined in the 19th century. But we're familiar with these things. The red-blue map or red-blue-purple map that you might see in election results. I call them theme maps or color maps. So the function of one of those is not about navigation. It's not about showing necessarily the relationship, the physical distance between one area or another. In fact, it's just a list of individual items that are categorized in a certain way. Did they vote mostly Democratic? Did they vote mostly Republican? Did they vote? Were the votes very mixed? And in that case, you can actually effectively have a map in which each of those different items is available. A person can tab through, or they could jump to an individual state, for example, and find out the answer for that. And it's effectively, just think of it as a list that also has a visual component. So again, with the list, with a list, it's a long list of things and it doesn't give the overall context. So what I would do is I would provide a summary in text that says the number of states that voted blue, the number of states that voted red, the number of states that voted purple, right? I'm using that as, you don't usually see the purple, but I do try to point them out. But you get the point, is tell them multiple ways. That's that redundancy I talked about. Give them multiple ways to consume the information, either as discrete elements or as an overall summary.
Okay. Yeah. You answered Isabella's question perfectly. She found it really helpful.
Well, that's okay.
Excellent. All right. Well, that concludes this webisode of Technically, and that also concludes season 1 of Technically.
Oh, you didn't tell me I was the season closer.
Yeah, you're the closer, man.
I would have put a cliffhanger in there.
Well, people are clamoring for a part 2.
Okay.
So you can go even deeper. So we'll have to keep that in mind for next year. Yeah, so thank you to everyone who has joined us over the past year, especially those who were here for every webisode. There are a few of you. And speaking of next season, we'll be kicking that off with Nobility's Eric Eggert.
Oh.
The title of his presentation is just fantastic. Are You Serious? The Good and Mostly Bad of Aria, or Aria, or however you pronounce it. Great title and a great topic. We haven't really touched on that yet. And so thanks again to Doug for that fascinating. That was, that gave me a lot to think about. I mean, some of the stuff that I'm working on myself outside of this and Tenon. Thank you to Claire from ACS for the captions, and of course to all of you for attending. Have a great day, and we will see you all next month.